All right, so today we're going to get into what are called trigonometric identities, fundamental identities. So we know how to use the unit circle now. There are ways to relate our trig functions to each other, and that's what we want to get into with today. And so there are reciprocal identities, and I'll just populate them all here. You can always pause the video, write everything in, and then start it back up if you want. And I'm just going to talk through them really quickly. Okay, so the first box, those are reciprocal identities. And we know all of this already for the most part. Right? We know that cosecant is the reciprocal of sine. We know that secant is the reciprocal of cosine, so on and so forth. I think the point behind the box here is to know that if I see sine theta written somewhere, I can always rewrite sine theta as 1 over cosecant theta, right? In other words, if I'm trying to figure out, if I'm doing something to where I've got sine of 20, then I know that I can always replace that with 1 over cosecant of 20. And there are going to be times when we're going to want to do that, whether we're solving trig equations or simplifying trig expressions. There are going to be times where we're going to want to sort of rewrite some of our trig functions in terms of another one, whether it's flipping it over or just writing the reciprocal like this. And I'll try to show you a couple of examples of those. Next, from our previous talks, you hopefully remember that the tangent, if we're going to use our unit circle, then to find the tangent of an angle, we want to take the y-coordinate and divide it by the x-coordinate. We also know that sine of the theta is the same as the y-coordinate. Cosine of theta is the same thing as the x-coordinate. So then it shouldn't be too much of a surprise to you to find out that if we substitute sine in for y, cosine in for x here, then we get this next identity, which is that the tangent of theta can also be written as sine of theta over cosine of theta. Okay? So it's a way for us to take tangent and turn it into a combination of sine and cosine if we ever need to. And there'll be times when we're going to want to. Same thing for cotangent. Cotangent, just flip that fraction over to where we've got the cosine of theta over the sine theta. Okay? And we know that we can rewrite cotangent with that. The bottom guys are Pythagorean identities. The first one comes from the fact that when we went through all of our unit circle stuff before, we came up with the equation of a unit circle that's in a coordinate plane, right? And that was based off of the x minus h squared plus y minus k squared equals r squared. And then everything simplified down because of the unit circle and the nature of the unit circle to this, x squared plus y squared equals 1. That's all in your notes from before. Well, again, since sine is the same thing as y and cosine is the same thing as x, should not be surprising that I can substitute in cosine here, sine here, and come up with this identity right here. Sine squared theta plus cosine squared theta equals 1. And then I need to be able to understand, we need to be able to understand that we can manipulate that equation however we want, right? We can subtract sine squared from both sides. And if we do, we're left with this guy right here, where cosine squared theta equals 1 minus sine squared theta, and so on and so forth. The other two Pythagorean identities here, 1 plus tangent squared is equal to secant squared. It's just a way for us to relate tangent and secant to each other. And then 1 plus cotangent squared equals cosecant squared. And again, it's another way for us to relate cotangent and cosecant to one another. Okay? And again, we need to be able to manipulate those equations. Now, these identities you don't have to memorize. We will give these identities to you. You just have to be able to use them. Okay? So, for example, we've got some ways that we want to take a look at in terms of trying to use these guys. So the first example here, we have been told that sine of an angle is radical 5 over 5, and cosine of an angle is 2 radical 5 over 5. And we want to find the value of each of the 4 remaining trig functions. All right. Well, tangent of that same angle, and I guess that needs to be said and not just implied, but all of those identities apply only if the angle is the same. The angle measure is the same that we're dealing with, right? So the fact that sine and cosine and tangent here all have the same angle is important. But anyway, one of our identities says that the tangent is the same thing as taking the sine of that angle and dividing it by the cosine of that angle, which means that I want to replace sine t with radical 5 over 5, and then divide that by what we know cosine to be, which is 2 radical 5 over 5. But remember that when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So I actually want to flip this bottom fraction over and multiply it into the numerator up there. When I do, this 5 and this 5 divide out to 1. This radical 5 divide out to 1. And we're left with just this 2. So multiply straight across, and tangent of t ends up being 1/2. Okay, with some good algebra, good fraction arithmetic. Now, if tangent of t is 1/2, cotangent becomes pretty easy. We just flip that over and get 2. Speaking of flipping over creating reciprocals, secant of that angle is the same thing as flipping over cosine. So you get 5 over 2 square root of 5. And now rationalize. Okay, move the square root of 5 up, so we get 5 square root of 5 over 2. And then we drop the radical. Remember, we don't drop the 5 also. We just drop the radical and make this 2 times 5. But before I do anything else, I know that those 5s will divide out. And so we're left with radical 5 over 2 for secant. Cosecant means that we need to flip over sine. So we make this 5 over radical 5. Then we've got to rationalize. So we bring the radical 5 up, drop the radical from the denominator, realize that those divide out. And so we're just left with radical 5. So we need to be able to work through and get radical 5 here. Okay? All right. Next one. Cosine t is equal to radical 10 over 10. So we've been told that. Cosine of some angle is radical 10 over 10. And then this says that the angle measure is between 0 and pi over 2. That's going to become important to us in just a moment. Find the value of sine of that angle using the trig identity. Well, if you go back to your identities, there's one that relates sine and cosine together. And that is sine squared of the angle plus cosine squared of the angle is equal to 1. So I'm going to take this and put it in for cosine. So that means I have to square that. So I got to take radical 10 over 10 and square it. So that equal to 1. So sine squared t plus, now when you square that fraction, you square the numerator and square the denominator, and you get 10 over 100. Which will reduce down to 1/10. Then I subtract 1/10 from both sides, and we're left with sine squared t equals 1 minus 1/10 is 9/10, and then we want to square root that. So we get sine t instead of sine squared. And when we square root that, you square root the 9 and get 3, and you cannot square root the 10, so it stays radical 10. That means we have to rationalize. And we see that sine t is equal to 3 radical 10 over 10. Now, we have to go back to where we square rooted right here. And remember in Algebra 2 class, you talked about if you square root in an equation to solve it, then you need to include the possibility of your result being positive or negative. It can be plus or minus, right? Well, that's where knowing that the angle is between 0 and pi over 2 comes in handy. The angle being between 0 and pi over 2 means that we're in quadrant 1. Since we're in quadrant 1, that means that sine has to be positive. So we'll keep 3 radical 10 over 10 positive. Okay, so using all of our knowledge now of that circle. Now, how to use some of these other identities. Next example, find the exact value of the expression. Well, secant squared of 18 degrees minus tangent squared of 18 degrees comes from that identity where 1 plus tangent squared is equal to secant squared. And so what we've done here is we've subtracted tangent squared from both sides. And so we get 1 equals secant squared minus tangent squared, which is exactly what that says. And since those angles are exactly the same, then all we have to do is come down here and say, well, this is just going to be 1. Right? The next one, tangent of pi over 3 times cotangent of pi over 3. Well, cotangent we can rewrite, and this is what I'm talking about, right? This is a time where we want to rewrite that as 1 over tangent pi over 3. So we're going to multiply that tangent pi over 3 times 1 over tangent pi over 3, which means that we get tangent pi over 3 over tangent pi over 3. And it doesn't matter what tangent of pi over 3 actually is. This is going to be the same, so this is going to divide out to 1. Because you're multiplying something times its reciprocal is another way to say that. Right? And then C, tangent 20 minus sine 20 over cosine 20. Looks pretty weird, right? But from our identities, we can actually rewrite that fraction as sine over cosine is how you get tangent. So we actually get tangent 20 minus tangent 20, which very obviously becomes 0. Because anything minus itself is 0. Next one, we're talking about tangent and secant again. And so we have that identity that says 1 plus tangent squared is equal to secant squared. Well, this tells us that tangent squared is 8. So we get 1 plus 8 equals secant squared. This is 9. And since it says find secant squared, we're done. Secant squared is just 9. So just a lot of different ways that we can use those identities to our advantage. Okay? All right. Some more examples of either using our unit circle or our identities, right? And this says, do not use a calculator. So we do not want to use a calculator. We need cotangent of 9 pi over 4. 9 pi over 4. Where would that land us? Well, the reason why we kept trying to find coterminal angles that are less than 2 pi and less than 360 is because that'll get us back into our unit circle and be able to use those values. 9 pi over 4 is more than 2 pi, right? 4 goes into 9 2 times with a fourth left over. So if I take 9 pi over 4 and subtract 2 pi from it, I'm subtracting 8 over 4, right? And then I get 1 over 4 pi. So pi over 4. So cotangent of 9 pi over 4 would be the same thing as cotangent of pi over 4. Okay? If that's the case, pi over 4, you've got to think about the coordinates for pi over 4. And pi over 4 is going to relate to, and you need to know this, it's radical 2 over 2, radical 2 over 2. And pi over 4 is in quadrant 1. So they're both going to be positive. Now, cotangent is cosine over sine. In other words, it's x over y. So what that means to us is that cotangent of pi over 4 is going to be radical 2 over 2 divided by radical 2 over 2. Well, if you divide something by itself, you always get 1. So you're going to get 1. Okay? Try the next one, cosine of 5 pi over 2, and see what you come up with. Okay? So what'd you do? 5 pi over 2 is more than 2 pi. It's actually 2.5. So if I subtract 2 pi from it to get a coterminal angle, I'm just going to get pi over 2. That means I want to go to pi over 2, which is the quadrantal that's on the positive y-axis, which means that our coordinates are 0, 1. The cosine of that is just going to be the x, so 0. The next one, we can use the even and odd function conversation that we just briefly introduced and haven't used a whole lot of just yet. This is what I mean. Secant and cosine are what are called even functions. That means that the secant of a negative angle measure is the same thing as just the secant of the positive angle measure. Okay? And the reason why we can do that is because if you think about it, from standard position, if we go clockwise or counterclockwise, let's say 30 degrees, clockwise and counterclockwise at 30 degrees will both put you at positive 1/2 and in the unit circle for the x value, right, for the cosine value. So those are the same. And secant's just the reciprocal of cosine, so of course it makes sense that that's an even function also. So instead of trying to worry about going clockwise 3 pi over 4 to figure out what the value of secant is, we can just do the secant of 3 pi over 4. So we can go counterclockwise and think about this the way that makes the most sense to us. So 3 pi over 4 puts us in quadrant 2. Those coordinates, it's an over 4. So radical 2 over 2 for both of our coordinates. Since we're in quadrant 2, we want to go left and up. So that means x is going to be negative. So the secant of 3 pi over 4 is going to be the reciprocal of cosine. So I've got to flip that over, go negative 2 over radical 2, and then rationalize. So negative 2 radical 2 over 2, these two divide out, left with negative radical 2. Okay? So just a thought process to get us through everything. Okay? The next one offers up another type of thought process. Here, we're subtracting some pi's from our angle measure, right? But we're subtracting 1,000 pi's. Well, remember, if we subtract 2 pi, then we're just going to create a coterminal angle for negative pi over 4, which means that whenever we subtract 2 pi from negative pi over 4, we're going to get the exact same xy coordinates on the unit circle. So it's not going to change anything. And if that's true for subtracting 2 pi, then subtracting an even number of pi's is going to be the same, right? So subtracting 1,000 pi's will still put us right back in the exact same position that we are when we are at negative pi over 4. So what that means is we can pretty much neglect that part of the angle measure and just take sine of negative pi over 4. Well, sine is an odd function. An odd function says that the sine of a negative angle is the same thing as the negative sine of the positive angle. So I would rather find the sine of pi over 4 and then just multiply it by a negative sign, right? So pi over 4 puts us at radical 2 over 2, radical 2 over 2, and that's going to be in quadrant 1. So these are both going to be positive. So sine is the y value. So I want to take negative radical 2 over 2 and just make this negative radical 2 over 2. Okay, see the trick there? A little bit of a trick in the next one too. So we're going to add 17 pi. So we're not adding an even number of pi's, which means that we're not going to end at a coterminal angle, right? But 16 pi's would be adding a bunch of 2 pi's, and so not change anything. So really, when we're adding 17 pi's, we're trying to add just pi, right? And so if I add pi to pi over 4, then I'm looking for a negative cotangent of pi over 4 plus pi will give you 5 pi over 4. Just do your adding two fractions. And so I'm looking for the negative cotangent of that. Well, 5 pi over 4 is an over 4, so the coordinates are both going to be radical 2 over 2. 5 pi over 4 puts us in quadrant 3, right? So quadrant 3 means we're going left and down, so both of these guys are going to be negative. Cotangent is x over y, so we go negative radical 2 over 2 divided by negative radical 2 over 2, which is silly to write out because you're dividing something by itself, so you just get 1. So you get negative 1, which ends up being negative 1. So lots of tricks to these trig identities, lots of tricks to these trig functions. Okay? But there you go. All right, I've walked through several with you. I am going to, well, I guess these next couple I need to talk to you a little bit about how to get these as well. So cosine theta equals radical 2 over 2. I want to find the value of theta. What is the angle measure that puts cosine at radical 2 over 2? And if you look at your unit circle, or if you remember your unit circle, for cosine to be radical 2 over 2, that means the x-coordinate has to be radical 2 over 2. Well, when that happens, the y is radical 2 over 2 also. So that gets you into one of your over 4 radians, right? Or your 45-degree angles. But which one? Because if you go around, you're going to find that there's 2 spots where the cosine is radical 2 over 2. So since we don't know exactly which spot we're talking about, we're going to have to write down both of them. The first one is when the angle measure is 45 degrees, which is in quadrant 1. The other one is when we're in quadrant 4, which is going to be 315 degrees. And so our radians are pi over 4 and 7 pi over 4. Okay, so that's how we work that out. Okay, you try to think through the next one. When are we going to have tangent of theta to be 1? All right, well, remember that tangent is y over x, so what I'm looking for are the places where the y and the x are going to be the same. Well, that's again when those coordinates are radical 2 over 2, radical 2 over 2. In order for tangent to be a positive one, then it can be when the coordinates are that or when they're both negative. So when are your coordinates both positive and your coordinates both negative? Well, again, that's going to put you in quadrant 1. So theta is going to be 45 degrees or pi over 4. Or that could also happen in quadrant 3, which is going to be 225 degrees or 5 pi over 4. Okay. All right, try to talk through the next couple here. See if you can't figure them out. Start the video back up and we'll talk about it. Okay, cotangent of radical 3 over 3. Well, cotangent I don't have on the unit circle, but tangent we do. So what if that means that tangent theta must have been 3 over radical 3? If I rationalize that, this tells me that tangent must have been radical 3. How did that happen? Well, think about tangent being y over x, right? So not radical 2 over 2, radical 2 over 2, because that would just be 1. It's either when the coordinates were 1/2 and radical 3 over 2, or when they were radical 3 over 2 and 1/2. If I put y over x, when is it that I'm going to get radical 3? Again, remember that you have to flip this guy and multiply. The 2's divide out. So, hey, there it is. It's when we have coordinates like this. And I want it to be positive. So in order for it to be positive, that means we got 1/2 and then radical 3 over 2, or negative 1/2 and negative radical 3 over 2. So when does that happen? Well, we got to think about this. So theta is going to be when the y is more than the x, when we're going more y than x. That to me, in my mind, means that we're going to be in quadrant 1 in the top spoke, which is 60 degrees. Or it can be in quadrant 3 when we're in that bottom spoke, right? So more y. Go to the spoke that's more in the y direction, which is going to be the 180 plus 60, so the 240 degree spoke. And then as radians, we get pi over 3. And then for the next guy, we would get trying to think. Well, then let's just divide this by 180 and see what we get. Yeah, 4 pi over 3. Sorry, it took me a second. Okay. All right, and the next one, secant theta. Where is secant radical 2? Well, it's the same place where cosine is 1 over radical 2. And when you rationalize it, it's when cosine theta is radical 2 over 2. Well, we know that. That's when our coordinates are radical 2 over 2. So that's when we're at 45 degrees in quadrant 1, or 315 degrees in quadrant 4. And so our radians would be pi over 4 or 7 pi over 4. Okay? Is how we work our way back into our angle measure. All right. The rest of this is just you working through this, right? Just working through the examples. Use a calculator to find the values of the trig functions, okay? You're going to have to make sure that you are in radians mode, right? Make sure that you are in radians mode. And let's go through and talk about how to put these in. We've got to have our calculator up, so bear with me for a second. Okay, we need our calculator. And we need our calculator to be, for these, if you look, bring this up. If you look, all of these examples are in radians. The 0.8, 3.7. I know that we don't have pi in there for those guys, but they're not degrees. So since they're not degrees, then we have to be in radians mode. So you have to go to mode in your graphing calculator and switch over to radians. So arrow down to radians, hit enter so that it's highlighted, and then we're in good shape. And then it just becomes a matter of typing them in. So sine of 0.8, you literally type in sine 0.8, 0.8, and hit enter. And that's the sine of 0.8, 0.7174. Okay? Tangent of 3.7 would be the same. Tangent of 3.7, boom, 0.6247. Okay? Now, if you want to type in cosecant of pi over 8, okay? Remember, cosecant is the reciprocal of sine. So I'd want to go 1 divided by sine, and then in parentheses, I want to type in the pi button. Second, pi here, divided by 8. And then close, make sure you close down your parentheses. Okay? And then hit enter, and that'll give you your value of 2.6131. Okay, but actually use the pi button. Don't use 3.14. Secant is the reciprocal of cosine. So we want to go 1 divided by cosine, and then in parentheses 3, and you can just type in pi, 3 pi divided by 7, and we should be in good shape there, which is 4.493 or 0.4940. Okay. I'm going to type this in again just to make sure I did that right. And I want to, this time, I'm going to put another set of parentheses around and do 3 pi, close my parentheses, then divide by 7 and close the parentheses. Okay. And then hit enter, and it's the same value, so it's the same. All right? So that's how you get these values out of your calculator when you're dealing with radians. All right? All right, so that gives you those values. And then you've got a bunch of examples here of what to do, how to get these out, either using, it looks like we should be able to use your unit circle to get all of these. Okay, so go through and stop the video, try to go through and think through all of these, and you can start the video back up. I'll show you the answers. And if you can't get there, then you got to come in and see me and we'll talk our way through it. And so here are all your answers. If you can't get to these, then we need to sit down and figure out why not. All right, that's it. Homework's out in Canvas. Knock it out, and we'll talk about it next class.